Hey everybody, welcome to Wednesday Physics. Today we're going to learn how to create a motion map. A motion map is another representation of the motion of an object. So everything about this is representing the motion of an object. So a motion map, which just kind of shows basically a stop motion or a strobe photo of the object and what it's doing, can be created. So as we mentioned in the video in class, lots of objects are moving, but we don't want to look at every single one of those objects. We want to focus on just one. So instead, we used the the single car, toy car. So here we have the 4 different videos of the different cars, and toy car 1 will be the one I focus on for this stop motion thing. So we're going to be looking at the toy car 1, just starting on one side and kind of going across. Although we should see some of the other ones as well. So let's get started. So I'll be saying many of these words. I'm not going to read you these words, but on the sheet. But I want you to use this sheet as kind of notes. The words are there to remind you of what each section is about. So I've got worksheet 1.2, motion maps Wednesday. And we're going to use this moving car here, and we're going to represent it moving in kind of a motion map. And let's do a couple different versions of that, and then you're going to try it and see if you can interpret and create some of your own motion maps later on. All right. So a motion map is used to represent the velocity, position, and also acceleration, although we're going to get to acceleration later. These cars are not accelerating. So the position and velocity, or speed for us, of the object at different times. So if I've got a car that's moving along, similar to the toy car, I could imagine kind of taking a picture of it at different times. In fact, if I take it at exactly 1 second intervals here, at exactly 1 second, then I would end up getting it pretty much evenly spaced apart. Well, if I want to create a motion map of this, then I'm going to put a dot where the car is at a given time at each of the seconds, and then I'm going to give it an arrow, put an arrow on that dot to show its velocity. So both the direction that it's moving and a bigger or smaller arrow depending on whether or not it's going slow or fast. So let's do that. So I've got the car. I got to pick a spot on the car to kind of put. So I'll pick the back tire. I'll put a dot there for the back tire. So that's where the car is at this moment. If 1 second later I see the car's here, I'll put another kind of dot right here. And 1 second later, I see the car is here. Put a dot. 1 second later, I see the car is a dot. Now I'm doing this, my head's in the way, on a number line. It's kind of like a number line. It's basically a ruler. I set up and I go from a 0 position. So I go from like a 0 position to some number. Now it doesn't give any numbers like 1 meter, 3 meters. It doesn't tell me how fast it's going, how much distance it's covering each time. So I just have kind of a location, and I can see that they're evenly spaced apart. That's telling me that the object's moving the same distance per 1 second. Right? One more thing before we put the arrows is we want to label the time of each of these points. So I've got, I can use a text here. The first dot is our first time. So that's actually the 0 second point. After 1 second, the car has moved to this point. And after another second, the car has moved to this next point. And after one more second, the car's moved to the last point. So now we want to put an arrow on each of these to show how fast it's going. And the length of the arrow initially is not that important. So I give it a little arrow. I then need to put an arrow on this car. The key here is that the arrow is the same length, because the length of these arrows are going to tell us the size of the speed. The directions by the arrow, and the length, it tells us how big or how fast the speed is. So I'll try and make them all about the same length. And so that's my first motion map of a car moving at a constant speed. I can then look at a car that's going faster. So it's the same thing. We actually see fewer cars because in that same amount of distance, it's going to cover more space. So I'm only going to see 3 of the cars rather than 4. But it's the same thing. I have my initial position of the car there. Yeah, it's moving, but this is the initial position. So this is the time, a little bit past the 0 point, right? A little bit past the 0 on the axis. Maybe it's out at 1 meter, 2 meter, 3 meter. I don't know. Put a little dot there for that car on the back wheel. A little dot on the back wheel for that one, and a little dot on the back wheel for that one. Once again, we need to label the time of each one. So that's time 0, time 1, and now time 2. So we actually are only showing 2 seconds worth of time. 0, 1, 2. Right? Remember that first one's 0. And then I need an arrow. Now, the arrows now need to be bigger or longer than the previous car, because it's showing that it's moving faster. So the longer your arrow, the larger your speed, and then the arrow tells us the direction. Now, even though the arrows themselves are longer than before, they are still all the same size for this particular car because it's traveling at a constant speed again. It's covering the same amount of distance, so I know it's a constant speed. We can also represent the car going the opposite direction, similar to one of the cars I'll do in the lab. So I'll put my dot here. Do I have to move out of the way? I don't know if I can do that. Let's see. I got my dot on that wheel, dot, and dot. And then label my time. Okay, we've got a time 0, 1, and 2 seconds. Now, notice I can start over here in some positive area, and I move in the negative direction there, back towards that 0 point. So I'll just put an arrow on each of those. Again, it's moving pretty fast, so I'll do just a little bit bigger arrows than we saw before. Oh, cool, I kind of cover that up. And last one there, bigger. So the key are these second 2 cars moving faster than the first one. We can also show more complicated, kind of some back and forth motion, and I'll show you that right here.